Today we're going to learn about translations. Vertical is f of x is equal to x plus k, and horizontal is f of x is equal to, in parentheses, x minus h. So we know that the parent function is f of x is equal to x. The parent function is the graph to which for every x input, the y input is the same value. So for x being equal to 1, y is 1, x being 2, y is 2, and so on and so forth. And this parent function makes a simple linear line spanning across the graph, with the x and y intercept being 0, 0. So translations are variations of this parent function in accordance to whether the graph is shifted vertically or horizontally. If we had a graph g of x being equal to x minus 4, what would this graph look like? Well, we see that there's no parentheses, so it has to be a vertical type translation. But instead of plus k, it's a minus k. If we plugged in 0 for x, so g of 0 is equal to 0 minus 4, we'd get g of 0 is equal to negative 4. And plugging in 0 for x tells us what the y-intercept is. So negative 4 is the y-intercept, which means the graph hits the y-axis at negative 4. In fact, the graph will look something like this. The graph is the same as the parent function, except now it's been vertically translated by 4. From the parent function to this new function, we've traveled 4 units in the negative y direction. How about this next one? H of x is equal to, in parentheses, x plus 2. Let's plug in 0 for h of x. H of 0 is equal to 0 plus 2. So h of 0 is equal to 2. So when the x value is 0, the y value should be 2. And in fact, the graph is going to look something like this. This is h of x is equal to, in parentheses, x plus 2. Why is it that the graph is translated to the left if we're adding 2? We see that in the parent function, the x-intercept is 0. But in this new function, the x-intercept is at negative 2. Why is the x-intercept to the left? Let's directly compare the parent function with the function h of x is equal to, in parentheses, x plus 2. How do we get the x-intercept? We have to set y to 0, which is the function. So for the parent function, we're going to have 0 is equal to x. And for the h of x function, we're going to have 0 is equal to x plus 2. So in one case, we see that x is equal to 0, and in the other case, we get x is equal to negative 2. So the x-intercept is negative 2 compared to 0. So that's why, for a horizontal translation, adding some value means that we translate to the left. Now, what would this last function look like, which is, in parentheses, x minus 3 plus 1? This incorporates both the vertical and horizontal translations. Let's look at the horizontal translation first. We know that a negative 3 means that it's going to go to the right. Meanwhile, the plus 1 for the vertical translation, like the plus k, means that we're going to translate this upwards. And so 3 to the right and 1 up is going to look like this. So this is what 3 to the right and 1 up looks like for the graph. Again, here's the parent function at 0, 0. We move this point 3 to the right and 1 up. And here we go. Hits the graph perfectly.